Hello, welcome. We are reporting from the SMES Space Station. I'm here with Mrs. McCorkle, finding out some information about the recent third grade space rotations that happened at the space station. Can you tell us a little bit about that?
Yes, so we did 4 different activities, and those 4 activities gave the students a chance to observe different parts of space, but there were some kind of questions raised by those activities, and so I kind of wanted to come on here today so I could kind of address those questions.
Okay, what were some of those questions like?
Well, so the first activity we did, for example, was a searching for the sun activity. So in this activity, students had to look around the room and find big images of our sun. And some of the images were really big, some were small, and they kind of had to figure out where all of them were, mark them down on a map, and then kind of discuss why they were easier to find or harder to find.
Interesting. Why did you use suns instead of moons?
Well, so a moon is not actually a star, and so we really want to demonstrate that most stars are so far away from the Earth that we can't see them very well. But our sun is obviously the closest, and so we're able to see it a lot better.
Did you do anything else with stars in these activities, these rotations?
Students were able to actually use white paint to splatter on stars in our very new space room that's still kind of under construction. We talked about how stars are different sizes. I actually have some of the observations that the kids made. They realized that some stars are far and some are close, kind of like what we talked about with our sun activity. They also realized that stars are different colors, and they realized that they are different sizes, and the splatter paint kind of demonstrated that.
So if they're different colors, why'd you use white paint?
That is a great question, and a couple of kids had that question as well. So the reason why we used white paint was because we wanted the kids to understand that even though the stars are far away in different colors, because they're so far away, they look like little points of light.
And stars are very far away. Mm-hmm. They're not right next to each other, but they make constellations. Why do they make constellations if they're not like sitting right, like Orion's belt is not sitting right next to each other? Right,
absolutely. So that's a great question too. And I think we had a couple of students who had that question as well. So stars, when we say that they make constellations, really that's something that we as humans do, is we look into the night sky and we see patterns. And there are actually different cultures that have different constellations. So like the Native Americans had a different set of constellations than the ancient Greeks. And so the constellations we're familiar with, like Orion's belt, are those ancient Greek constellations. And really it was just it's kind of like using your imagination, imagining a connect the dot activity, but looking up in the night sky.
What was another activity that you guys did in this rotation?
Probably our toughest activity, just because we faced a lot of challenges, was our water activity. So the original intention was to paint on the concrete with water, and to do one in the shade and one in the sun, and see how the sun would, what would happen to the water that was in the sun versus the one in the shade. Students were still able to make predictions as scientists, and based on the observations they were seeing, of which one would dry first. And a lot of them, they made some observations. Again, I have those here, and they said the one in the sun will definitely dry first because the sun gives us heat and light. So that's some of the forms of energy that it gives us. And so that heat and light is going to help the water evaporate. So.
Okay. And there was a 4th activity as well in this rotation.
In this activity with gravity, we actually were talking about how gravity is a force that can be overcome. But the gravity on Earth, it can be overcome with a powerful enough force. So we used a golf ball and we used a blow dryer. And so the air pressure from the blow dryer caused the golf ball to look like it was floating, as you can kind of see in these videos. But then we also used a styrofoam ball. And I believe we had some kids have some questions about that. They said, why did the styrofoam ball fall? It fell down, whereas the golf ball was a little better unless somebody stuck their hand underneath it. And the reason for that is that the styrofoam ball had more mass. It was a heavier object. And so the air pressure wasn't a strong enough force to overcome the gravity in that situation. So the ball was also so big that it would move itself out of the airstream, and then that air pressure wasn't there to keep it floating.
We're going to sign off from the SMES space station right now. I don't want to turn off the anti-gravity though.